In the previous video, I showed the fine viewers how to measure and calculate the coefficient of friction for plastic sliding on wood and sandpaper sliding on sandpaper. To pull a box across a flat surface, such as a level table, the pulling force Fp has to be larger than the force of friction, Ff. The force of friction is the coefficient of friction times the box's weight, W. The coefficient of friction is always a number between 0 and 1. It represents the percent of the object's weight needed to overcome friction and get the box moving. For example, if a box weighs 10 newtons and the coefficient of friction is mu equals 1.0, then the pulling force to get the box moving is 100% of the weight. In other words, pull with the entire 10 newtons of force to get the box moving. If the coefficient of friction, mu, is 0.5, a pulling force of only half the weight is needed, just 5 newtons. If the coefficient of friction, mu, is 0, any pulling force will make the box move. Most games require objects rubbing against each other, such as tires on a road or the side of a car hitting a wall. We can see how Unity handles friction by setting up a new 3D core project. I called mine Motion Module Project. Once that's open, go to Create, 3D Object, Cube, rename that Ground, then go over to the Scale, change X to 15, Y to 1, and Z to 100. That'll give us a ground to work on. Let's also add another cube. That one's buried in the ground, so let me drag it up so we can see it. Set the value to y is equal to 1, so it's on the surface of the ground. It's hard to see because it's white, so let's add some color. Go to Asset, right-click, Create, Material. That will give us a new material. Go to the albedo, click on this white box, change the hue and the lightness and darkness. It will give you a preview of your color here. Once you have a color you like, you can drag that onto the cube to color it happily. In order for it to work with the physics engine, select the cube and add a component called Physics Rigid Body. It'll give us this component here that will tell us the mass is equal to 1 kilogram and it is using gravity. So if I drag this object up by using the green arrow, push play, it will drop back down to the ground because gravity is on. Let me reset the cube position in the y direction to 1 so it's sitting back on the ground. Next, we want to see if we can push the object forward across the ground. So go back to Add Component, Physics, Constant Force. That gives us a new component here. The force has 3 numbers to it. X would be a force that would push left and right, Y would be up and down, and Z is forward or backward. So let's add a force of 1 Newton. Push play to see if that's enough to get the object moving forward. And you can see nothing is happening. That means there's too much friction for the cube to move across the ground. Let's raise the number up to 10 and see if that helps. And there it goes. So somewhere between 1 and 10 is a number that will be enough to overcome friction. Let's go back down to 9, see if that works. Okay, with 9 newtons, nothing happens. There's still too much friction for 9 newtons to overcome. Try 9.81. That may seem like a weird number, but it is enough to get the object moving. So why 9.81? Well, that's because 9.81 is the acceleration of gravity on Earth's surface. To see that in Unity, go to Edit, Project Settings, Physics, Gravity. You notice we have three numbers, but x is 0, z is 0, and y is minus 9.81. So that represents the downward acceleration of gravity. If you take the mass of 1 kilogram and you multiply it by the acceleration of gravity, you will get the weight of the cube. In this case, our cube would weigh 9.81 newtons. We can use that information to calculate the coefficient of friction for this cube and ground surface. The coefficient of friction is just the pulling force, or the pushing force in this case, of 9.81 newtons divided by the weight of the cube, which is also 9.81 newtons. So the coefficient of friction mu is just equal to 1.0. That means the default value for Unity's friction is the maximum amount possible. This makes sense because it gives more interaction in games. For example, that high level of friction will cause the object to roll instead of just traveling smoothly. That's it for this video. In the next video, I'll show you how to get more control over friction by adding physics materials.